Imagine yourself swimming on the sea's surface and gazing down into the azure depths. Abruptly, there's motion coming from underneath, a white dot, a blur that immediately becomes a rapidly accelerating figure. It changes from a vague white and gray shape to a big wing-like fin, two black eyes, and an open mouth. Hello, ocean adventurers. This is Predator of the Deep, your go-to channel for all things sharks. Subscribe now to never miss out on exciting shark updates and discoveries. In today's video, we're going to look at what if great white sharks were the size of megalodons. The image changes from an indistinct patch to a large white smile in under 3 seconds. A great white shark, measuring around 5 to 6 meters, has a jaw of cartilage about 1 meter wide, lined with 5 rows of about 300 triangular serrated teeth. But before we proceed to further video, if you're new to this channel, remember, go ahead and hit the bell icon to subscribe so you won't miss the informative videos we will upload in the future. What if great white sharks were the size of megalodons? The waters around Guadalupe Island in Baja California are home to a large number of white sharks, and the crystal clear conditions make it easy to spot, photograph, and identify individual sharks. The research team Marine CSI has recognized 380 people at Guadalupe using photo IDs, with the majority of these identities coming from community scientists working from the cage dive boats. The conditions in the Farallon Islands to the north are significantly more clement and favorable for research than in the murkier seas. Dr. Paul Kanive and a group of researchers based in Central California identified around 300 adult and subadult white sharks by picture ID between Santa Cruz, the Farallon Islands, and Bodega Bay in May 2021. The crew was able to document this small but thriving population of white sharks by taking over 1,500 photos of dorsal fins. In the early 1980s, the California team discovered that a white shark's dorsal fin is similar to a fingerprint, despite the fact that many of them have noticeable scarring and sporadic abnormalities from interactions with boats or other sharks. Imagine now that a shark is 3 to 4 times larger, with a mouth that measures 2.9 to 3.7 meters and teeth that are 18 centimeters long. The teeth also have prominent serrations that resemble a larger form of a white shark's tooth. The largest shark to have ever lived, the Megalodon, could reach lengths of up to 20 meters or 60 feet. Megalodon, which means big tooth in Greek, possessed 6 or 7 rows of teeth, according to descriptions found in the fossil record. With 24 in the upper jaw and 22 in the lower, the front row teeth totaled about 46, making a total of about 276 teeth in a jaw measuring 2.7 to 3.4 meters. Until it went extinct some 2.6 million years ago, this magnificent shark was the top predator in the ocean. Megalodon's fossilized teeth and jaws bore similarities to one another, leading experts to hypothesize that the extinct fish was a larger version of a great white shark. A 2019 study established that habitat fragmentation brought on by the cooling oceans caused the Meg to go extinct about 3.6 million years ago. The authors, led by paleontologist Robert Bossenecker, hypothesized that the emergence of the great white shark may have played a role in the megalodon's extinction. The idea that great white sharks may have contributed to the permanent extermination of their larger cousins from the fossil record has now gained support from a recent study that was published in the journal Nature Communications. The whole contains the truth. Because shark teeth are highly calcified, they make excellent fossils. Sharks can shed thousands of teeth in their lifetime, therefore they offer special insights into the past. The group, which was led by scientists from Leipzig, Germany's Max Planck Institute for Evolutionary Anthropology, examined zinc isotopes in fossilized teeth belonging to megalodons and white sharks. Using the teeth of over 100 sharks, selected from both extant and fossilized species, the scientists verified that the zinc isotope composition of modern sharks corresponds to their ecological niche. This research builds upon a prior study that demonstrated zinc isotope ratios are markers of tropic level and food in Arctic marine mammals. The amounts of zinc isotopes in modern mammals' teeth correspond to their position in the food chain. Higher up the food chain are animals with lower zinc isotope levels. Sharks that consume little fish, for example, have higher zinc levels than sharks at the top of the food chain that eat whales. The scientists proposed that the same kinds of prey that the much larger shark ate were also devoured by prehistoric great white sharks, based on mineral research. The smaller sharks may have faced competition with the megalodon for food if the great white was consuming the same kinds of prey. If true, they may have had a role in its final death, in addition to possible alterations in other ecosystem components, such as climate. This data lends credence to the hypothesis that the giant megalodon's competition with it may have contributed to its eventual extinction on the high seas. Not descendants, cousins. The belief that white sharks of today are the smaller relatives of Megalodon has its roots in the similarities between the form and structure of their teeth. Because there isn't a comprehensive fossil record, scientists have created an image of the Megalodon that resembles an enormous great white shark. This vision of a vicious, ship-devouring super predator has captivated many, inspiring numerous Shark Week episodes and films like The Meg. The Megalodon was first named by the Swiss naturalist Louis Agassiz in 1843, thereby formalizing the association between white sharks and this animal. Agassiz classified Megalodon into the same genus as white sharks, Carcharodon, based on his observation that both the fossilized teeth of Megalodon and great white sharks were serrated. However, recent studies scrutinizing the tooth structure and root type confirmed that Megalodon bears no resemblance to great white sharks. Thus, scientists assigned Megalodon to the new genus Carcharodonts. After conducting additional research and analyzing teeth, scientists reclassified Megalodon into the genus Otodon, indicating a different lineage from the great white shark and a closer link to the extinct Obliquus. Rather, it is thought that white sharks and mako sharks, both members of the Laminidae family, are more closely related. The broad-toothed mako shark may have been the ancestor of the contemporary great white shark, according to fossils found in the Carcharodon hubeli type of shark. Nyberg and Ray of Duke University, as well as Charles Giampaglio of Wright State University, compared and contrasted the great white, megalodon, and extinct mako teeth using computer-assisted imaging and measurement techniques. They came to the conclusion that, while obviously different from megalodon, the extinct mako and its great white teeth and roots had a similar shape. Rather, a smooth-toothed, somewhat sized relative of mako sharks gave rise to white sharks. Otodus megalodon, also referred to as megalodon, is a type of megatoothed shark that lived in oceans all over the world between 23 and 3.6 million years ago. Its maximum length was possibly 20 meters. In contrast, the largest great white sharks of today are only 6 meters in length. There have been several theories put forth to explain the gigantism and eventual extinction of the megalodon, one of which may be nutritional competition. In a study funded by the U.S. National Science Foundation and published in Nature Communications, scientists examined zinc-stable isotope ratios in fossil and extant shark teeth from various parts of the world, including megalodon and great white shark teeth. With this new technique, scientists can now look at an animal's trophic level, or the higher up the food chain it feeds. Researchers compared the tooth zinc isotope signals of many extinct early Miocene and early Pliocene species to those of living shark species. To learn more about the interactions these species had with one another and with older megatooth sharks, Otodus chubotensis, as well as with the present-day great white sharks, the researchers examined the zinc isotope ratios in the teeth of early Pliocene megalodons and modern great white sharks. Michael Griffiths of William Patterson University stated, "Our results show that both megalodon and its ancestor were apex predators, feeding high up their respective food chains. But what's remarkable is that zinc isotope values from early Pliocene shark teeth suggest largely overlapping trophic levels of early great white sharks with a much larger megalodon. The findings suggest that the prey that both shark species hunt at least somewhat overlaps. Our results appear to support the possibility of dietary competition of megalodon with early Pliocene great white sharks," stated Kenshu Shimada of DePaul University in Chicago. White sharks receive a lot of attention, much of it bad. We cannot ignore the current threat to the existence of many shark species as we learn more about the ties that sharks have with one another across time and their function in marine ecosystems. The overfishing of shark species has put nearly 1/3 of them in danger of going extinct. If we don't take action soon, a large number of sharks today will follow the megalodon in much less time. Don't forget to like the video and hit the subscribe button so you won't miss any new videos from our channel. Thanks for watching, and see you all soon.